This is 7-6 Notes. Today we're going to be talking about graphing exponential functions. These are just equations that have exponents in them. So the very first two types are the types of graphs that we'll see. We'll see ones that look like this. That's called a growth graph. That means the base number in the equation is bigger than 1 or -1. For example, this top curve is y equals 2 to the x power. Starts near 0 and continues to grow up. The next equation down here is y equals -2 to the x power. Still starts near 0, but instead of going up, this one goes down, what we call exponentially. This next one's called a decay graph. This is when the base, or the bigger number, is smaller than 1 or -1. These are normally fractions or decimals. So for example, this top line is y equals -1/2 to the x power. So it starts way up high and curves down towards 0. This next line is y equals -1/2 to the x power. This starts way down low at the negatives and goes up towards 0. So when it's coming towards 0, it's what we call a decay graph because it's going towards 0. So problem number 1 is asking, does the table or rule represent a linear, that's a line, or exponential, that's these types of curves, function? So the first problem, they just give us a table of x, y values. Now you could graph this out, make a little t graph, and see if it's a line or a curve. That's one way of doing it. The other way is to look for the pattern of the y's. So if I look for the y's, to get from 1 to -3, I could subtract 2. But with that same pattern, could I subtract 2 to get from -3 to -9? No, that wouldn't work. If you can add or subtract in the same pattern, that is called a linear function. This, though, to get from -1 to -3, I could also try multiplying by 3. And then from -3 to -9, I can multiply by 3. That works. And -9 to -27 is another multiplication of 3. So if you can multiply or divide the same number to get to the next y value, that's called an exponential function. Okay, again, adding or subtracting to get to the next number is linear. Multiplying or dividing to get to the next number is exponential. This next problem is just an equation, y equals 3x. Is it linear or exponential? Well, exponential, do you see an exponent anywhere in this problem? No. So it's not exponential. An exponential function has to have an exponent. So this has to be a linear function. And your reasoning there would be there's no exponents. Okay, problem number 2, evaluating a function. So it says, suppose 30 flower beetles are left undisturbed in a warehouse bin. The beetle population doubles each week, gross. The function f of x equals 30 times 2 to the x power gives the population after x number of weeks. How many beetles will be there after 56 days? So the hint says, well, start with how many weeks are in 56 days. So to find the number of weeks, I take the 56 days and divide by 7, because there are 7 days in a week. So that means that there are 8 weeks. So I want to know how many beetles are there after 8 weeks. This is going to be my x value. So I'm going to use this equation and I'm going to plug 8 in for x. So I will have f of x equals 30 times 2 to the 8th power. Now using order of operations, I have to do the exponents first. So I'll have 30 times 256, which is 7,680 beetles. So if it starts out at 30 beetles, they'll exponentially grow to be 7,680 beetles after 8 weeks. Okay, problem number 3 is graphing. So we're going to use this graph over here. So it wants the graph of the equation y equals 3 times 2 to the x power. Now for this, I'm going to make myself a t-table. Now my x values are always going to be -1, 0, 1, 2. So you want to use these same ones. So then I just put the equation part in the middle, so 3 times 2 to the x power, and the x number is what's going to change. So -1 goes in for negative the x one here. 0 goes here, 1 here, then 2. So now I can use my calculator and plug this in all at the same time. So 3 times 2 to the negative first power is 1.5. So I'm going to put that number on the y column, 1.5. Then I do 3 times 2 to the 0 power, which is 3. 3 times 2 to the first power, which is 6. And finally 3 times 2 to the second power, which is 12. So now to graph these, the points I want to graph are the x, y values. So my x for this first line was -1, my y was 1.5. My second point should be at 0, 3, then 1, 6, and 2, 12. So then I go to the graph and I'm going to graph these. So from here I go -1, up 1.5, put a dot. 0, up to 3, put a dot. Over 1 to the right, up to 6, put a dot. Over to 2, and up to 12. This will be just a little bit off the graph. Now because this is an exponential function, it's going to be a curve. So you can kind of see the curve. You can't connect it straight line. And I can kind of extend it because I know that if it goes up at the top here, it should come down and be near 0. It won't ever cross the 0 line, but it'll get really, really close. So make sure that your curve here does not cross the x-axis. It just gets really close. Okay, so that's how you graph an exponential function using a table. Next, problem number 4 says evaluate each function over the domain of -2, -1, 0, 1, 2, and 3. Now domain, if you remember back to semester 1, are the x values. So they tell you in this table what numbers to plug in. So they want -2, -1, 0, 1, 2, and 3. And then they're asking, as the values of the domain, so as the x values increase, do the values of the range are the y values, so does the y numbers, increase or decrease? So as this goes up, will this go up or down? So they give you the equation here, so I put that in the middle, 0.5 times 3 to the x power. And now I go to my handy dandy calculator and I plug these numbers in. So 0.5 times 3 to the negative second power, whoops, is a little itty bitty decimal, 0.0555. Okay, and then I do 0.5 times 3 to the negative first power. That's a little bit bigger of a decimal, 0.16 repeating. And then I do 0.5 times 3 to the 0 power, and that gives me 0.5, or 1/2. And then I do 0.5 times 3 to the first power, and that's 1.5. And then 0.5 times 3 to the second power is 4.5. And then finally, 0.5 times 3 to the third power is 13.5. So if I look at this table, are these y values increasing or decreasing? Well, they start really small and they go up to 13.5, so I'm going to say that they are increasing.